Okay, so I just keep adding, I can keep adding elements on to this, if I want 5, 7, so on. But obviously this is just to give you a sense of how you work with a list. So I'm going to take this away and get back to where we were with the Fibonacci sequence here. Okay, so we have set up a loop to process up to wherever the user wants us to go with an input term. Okay. And we said we want to reuse this method. Partly I want you to get used to understanding how you reuse, because that's the object-oriented way of designing. So the other is we've already tested this out. So this logic we know works exactly as we want it to if you get a Fibonacci number. Now what we are saying is the user, if they give us, well, a number 6, then we want to accumulate everything from the first term to the 6th term. Okay, so how do we go about doing it? So there are 2 things we need to do. The first is to find each of the Fibonacci numbers, starting with the first term, right? So how do we get the first term? We know that this does the work for us. So how do I get the Fibonacci number for the first term? Do I use if I use input term here, some of you have done that with this work. Okay, Megan, why would it not work? It would just give me 6. So that's, if I just wanted the Fibonacci number for 6, I would just use this. So the input term doesn't work. So what should I use instead?
Right, but I declared an integer called starting value in my one, and then I put starting value in my parameters, and then I add the integer starting value with it.
Okay, we could do that, but here, to make it simpler, is there a simpler way without adding in another variable? Yeah, we could just go with the index, because the index basically goes from the first term up to wherever we want to stop. So this is going to be a recurring idea that comes up anytime you work with loops, is when you're looking for a particular term, you basically, that's why in loops the value, you call this variable an index, so that you can index into lists or arrays and so on. Okay, so this gives us, if we call the method, what's it going to do? This takes an input term and provides us the associated Fibonacci number, right? So if the term is 1, we get back 0. If it's 2, we'll get back 1. 3, it should be 1, and so on. Now the question is, not only do we want to get back that one number, but we want to keep accumulating it, right? So and we know that we can add to a list by using the add method. Okay. So what is the value of this? So the first time we add something, it's going to go into slot 0. The second value we add is going to go into slot 1, and so on. So the question is, what do we keep adding here? So since Megan, Eric, and Lev, I think, well, let me ask Ashley, Do you know what yeah. The result, when you say result, what is the result? Okay, like what we did with summing up. So you say just declare an integer like result or sum, and then what do we do? Remember what's this going to do? It's trying to find the Fibonacci number, gets us back. So if you're doing like what we have discussed, an analysis of business requirements, and if you're setting up variables, names that mean what they actually do, what would you call this? Okay, Fibonacci result, or even simply Fibonacci number, right? It's going to, this finds a Fibonacci number and gets it back to us. So we could do what? Get this value into this variable, right? Okay, once you have this, what would you do? Let me ask Kash. What's it? Yeah, you fell asleep. Okay. Now, so what does this do? This method is taking in a value, right? Megan told us that this is going to be each index value starting from 1 going up to whatever the user has provided us. So how many times will we go through this loop? Unlimited. What determines? Let me go to Bolaji. How many times will we go through this? Kash said unlimited. What's it? So what would determine the number of times we go through this loop? How many times will I go through this loop? Just once? Krista, how many times?
You're going to get your input, you share.
Okay, the input term will determine it. So if I say 6, basically it goes through it, starting at 1, goes through it 1, 2, 3, 4, 5, 6 until it reaches 6. Okay, because that's the number of terms we need to send back to the user. Okay, so this is going to go through it, let's say 6 times, if the input term is 6. So what do we add in here?
You're going to add Fibonacci.
Okay, the Fibonacci number is what we find for each of the terms, starting from 1 going up to whatever the input term is. So we are going to add this Fibonacci number, and do we have to set anything on this side, the assignment statement? Do I need to say something this side? Okay. We are using the object-oriented list, right? So what is it doing? It's just taking the value that's in the Fibonacci number and putting it in the next slot. So if there were 6 times that it goes through this, it's going to create 6 slots. So it starts with an empty list and keeps adding one at a time, 0, 1, 2, 3, 4, 5, 6. Okay, so, and then what do? We just return back that list. So that's what we are promising. Okay, so now that we know how to set this up, let's go into our test and see what we need to do. We can do it one of 2 ways. The expected list, we could start with, if we say input term equals 0. So if the input term is 0, the expected list is going to be what? If I give, and so you're going to have two lists. One list is your list of the expected values, and the other is the actual list. So I'll go back to somebody else this time. Let's see. Forgetting your name. Chris, right? Chris. So what's my actual list? Okay, I can declare my actual list to start if you want to declare it, create the object. But where do I get my actual list from?
You get your actual list from our sequence class.
Do we have a sequence class?
Or from our method, I mean.
Okay. What's the name of the method?
It's find Fibonacci sequences.
Okay, find Fibonacci sequence. How do we get access to that?
We would make a object of the method.
Okay, we would need to make an object of this calculator class because all the two methods that we have here are both what type of methods? Object methods. But we could also make a method belong to the class, right? So right, the first, and this is to show you the distinction between this method here is an object method that we call by creating an object. But these kinds of calculator methods, you can see that we don't have any data here, so they're not acting on any instance variable. Okay, so when you don't have instance variables, you could create these methods as belonging directly to the class. Does anyone know how to make this method, the second method, to contrast it from the first? How do we make it belong to the class? Okay, Logan?
It could be static, or static.
Okay, if you just put static here after public, this makes this class, this becomes a class method, just introducing static. So it belongs to the class and not an object or instance of the class. Okay. And what does this imply? When you go back to want to call this, how can you call this now?
Instead of creating an object and calling it from that object, you just have to give the name of the class and then tell it the method name.
Yeah, as Eric pointed out, you can now find it without having to pass in, create an object of that class. And then when you call this method, what else is it expecting? A parameter, and what's that parameter? Okay, we are saying we are starting with input term 0. So, okay, so for our expected list, okay, what do you think this? Okay, so for our expected list here, how many of you know what you need to add in? Okay, Eric, and who else knows what I need to add here? Okay, maybe.
I'm guessing, but do you have to put your input term in?
If we put our input term, so if it had been 6, would we add in 6 here? Remember, this list is our expected list. So the input term, well, I guess we can't have an input term of 0. We've said we are starting from 1. Okay, so what would the expected list consist of for the if the input term is 1? Logan?
It'll just be 0.
Okay, it's just 0. So the first term is 0. So we are expecting a list which has just 0. Now, if we said now I have to obviously add this in, and then I said it's going to be a collection, so we do a collection assert to check if they're equal, and what are we checking to see if they're equal? Let's see, I lost somebody who's not answered so far. Bolaji, what are we checking? Let's see if they're equal. Okay, the expected list and the actual list. And you can specify something like input term equal 0. And then you can keep adding, like, so this is just to check for the first term, and usually you want to, well, at this point I would actually run this to see this is working for the first term. So I'll build a solution to make sure that there are no compilation errors. Go to my test explorer, and let's see if an object reference is required. Okay, so let's see. Okay, so what I've done here is I've created a static method, and I'm calling a method that is not static. So obviously it's complaining, so it's saying I can't call one type of method from inside a different, so I can't call an instance method. This is an instance method from inside of a static method. The way you can resolve it is either make this also an instance method or make this a static method as well. So I'm going to make both static methods. But if I make this a static method, I'll have to make a change somewhere else. Where would I need to make a change? Okay, in the test, so you'll have to go back here, and everywhere where we use this instance, so I have this, I'll comment this out. I don't need an object here. I just need to get it directly off of the class. Okay, so go ahead and build this now, and run the test. See if you should be seeing 2 tests now once you build the solution. And okay, now this is only for the first term, so we want to add in more terms. So how do we do that? We said that we want our test points to be input term 1, input term 2. Expected list becomes what if we have 2 terms? 0 and 1. So would I have to say add 0 and then do another add for 1? Krista, what do you think? That's the constraint here. You can only add 1 at a time, unless you have a pre-existing list, then you can just say add it to this list. So, so we can only add one integer at a time. So do we say 0 and then expected list dot add 1? Anyone have? Okay, Liv, what do you say?
No, it already has 0 in it, so I would.
This list already has one element with 0, so we are saying add something onto that. So if we did this, it would now have 3 elements. So we want to remove this and just keep this. And what else do we need to do before? So I want to check this. If I just ran this now, would it succeed? If I did this test. Gosh, would it succeed? Would it run if I ran this? It ran earlier. All I'm doing is saying take input term, 2 terms, expected list is this. Right. So what do you think? Should it work now? It should work. Okay. How many of you agree with Tosh? Okay. So Chris, you agree with Tosh then that now it should run. Okay. How many of you don't agree with it? Or with that? Okay, Krista, do you know why it may not work? Balaji? The thing is, the expected list now has changed, right? Has the actual list changed? When did we run our actual list over here with the input term being 1, right? We have changed the input term. So each time you change some input parameter, what do you need to do? We need to get a change the actual. And for getting the change the actual, what do we need to do? What changes the actual? When we call the method in the calculator class. So basically you have to call it again. So this statement has to be run again with the new input term. So now if we were to run this, it should pass. And you can keep, obviously you want to keep adding in. So let's see, for 6. I just copy it and paste it and then make it 6. So if it's 6, what do I need to do? Add, so it's going to be 0, 1, 1, then expected list, so I'll just add this. I need to add it to
I had run all, it only runs my first.
only the first one here, so you're not seeing the second test. Okay. Can anyone point out what makes this a test class instead of just a regular class? It's this, it's called a decorator or an attribute on top of this. Now, it makes this a test method by having this. So what you need to check is, do you have this attribute on top of the method? Okay. So that's what tells C# that it's a test method. Okay. So Are all of you running tests, and is it coming back green now? Okay. So this is, so one of the things, we have been obviously doing this without any user interface. The other concept that I said think of or work with, which Eric has done, is to find Fibonacci number by recursion. And one of the reasons that Fibonacci works with recursion is each of the numbers that we are getting, other than the two seed numbers, is basically you're adding two previous numbers. So what is the concept of recursion? Caleb?
It's a method that calls itself.
Okay, you're basically calling itself. So and it gets to be very useful. Like, for example, if you want to find all the prerequisites for a particular course, let's say for 452, what are the prerequisites? You have 450 and 353. But can you start, let's say you're entering the MIS program and you want to figure out what courses to take in what sequence. Your 452 is the final course that you're taking. So if I say, okay, you have to take 452, you need to take 450, and miss 353. Okay. Now, so can your advisor tell you, okay, take 353 this semester when you're getting into the MIS program? Why not?
Because it's prerequisites for 450 and 353.
Okay, so for 353 for sure there are, I'll just try to do this. So I'll have missed 352, missed 351. Okay, so let's say I want to get the prerequisites for this. I cannot stop with just this, but there's another layer of prerequisites, and these in turn might have other prerequisites. So how do I find out how many levels to go? Would I know?
You have to figure out a way to instead of calling the method, you just return the value.
So when do I stop? Yeah.
You would stop when it doesn't return anything on the next column. So like if you got down to 351, I don't think that has any prereqs, and you called the find prereq method or whatever, it would say there's nothing here, so that's the end of the.
Yeah, so essentially you have to take all the prereqs and then find out if they have any prereqs, and then keep going down that chain or list until you come to where there are none. And the only way you know that there are none is when none show up, when to stop. So that is, I have not been able to figure out a way to do this other than to use recursion. So you have to keep calling itself until you come back with nothing left. So it's an interesting concept. Sometimes it sort of makes you have to think fairly deeply. So for example, Eric came up with her solution, but it clearly you included everything that we had and added something on. I would like for you to think of, to solve it using recursion, again, to make you think in different ways, and that there are multiple ways of solving a problem, and you have to figure out which is going to be cleaner, more efficient. So finding a Fibonacci sequence, I want you to see if you can, so if you have the method, find, so let's say you have public, and let's make all of these static. So So if you're finding a Fibonacci number by recursion, this is going to be the equivalent of the find Fibonacci number, except we use recursion. So so it's going to return an integer, and it's going to take the same parameter, which is an integer input term. Okay. The only difference, well, I guess I'll have to set up in Fibonacci number. Return. Okay. The requirement for this to be a recursive method, what is the characteristic? What do you need to see inside of this? Somebody other than Eric? Yeah, Logan?
I would assume a bunch of calls, calling the method over and over again.
Calling which method?
First you would call the find Fibonacci number, and then you would start calling the recursion.
Well, this method is going to do the recursion for us, so Liv?
It calls itself.
It's only going to call itself. So you're not going to call this. So somewhere inside here you'll have to call this, and this is the part you'll have to figure out. And Eric also has to make a cleaner version of this. Okay, so again, as I said, I want you to think in different ways, and and while this is, in this case, you might say, well, this works fine, and it's actually, I think this approach might be even simpler to understand. It actually follows the logic more closely. So try this out. The other thing that we will explore next class, and I'll also get to some of your project, but we need to, right now, we are testing through a test framework. I want to connect it up to our user interface, so we'll get into controllers and views next class to see how we can use these methods. So a little bit of the project, we'll discuss this Fibonacci number by recursion, and also setting up a UI. Next week, we'll move on to, I guess some of you said you're interested in the college basketball, so we'll use that as the application to work on. But I want to have this simple example to set up the MVC with testing. Okay. Yeah. So work on this, make sure you're having all of these pieces working when you come next class. Try this out before coming to class. And always when you have a method, make sure you have an associated test for it. Okay, that's it.
Right.